Dan Oak, and I'm a student at Athabasca University, and I'm currently taking the course Computer Science 444 Embedded/Robotic Programming. And if you've been following the videos that I've been posting to the course forum so far, you'll know that I've been going through the SparkFun Inventor's Kit Guide and showing you how I've completed a couple of the projects. So in one video series that I've posted on the forum, I've went through Project 1 and the associated coding challenges with that project. And then in a separate video series I posted to the forum, I've went through Project 2 and its corresponding coding challenges. And in the last video I posted, I went through the first circuit associated with Project 3, so Circuit 3A, which dealt with servo motors. And in this video, I'm going to go through the second circuit of 3 circuits within Project 3. And the second circuit is Circuit 3B, and it deals with the ultrasonic sensor, specifically the HC-SR04 ultrasonic sensor, which is a common one that comes in a lot of those Arduino kits, and the one that came in your SparkFun Inventor's kit. So we're going to be going through that, as well as dealing with an RGB LED. So this is to keep me on track. This is generally what we're going to talk about. Again, we're going to be going through Circuit 3B of Project 3, and we're going to talk about the RGB LED and how we can change the color of it based on the distance measurements from the ultrasonic sensor. The components we're going to be using is the ultrasonic sensor, which includes a trigger and echo pin, and the RGB LED that's going to be connected to 3 PWM capable pins. And I'm also going to be discussing the importance of using interrupts for non-blocking distance measurements, which allows the program to retain responsiveness while waiting for sensor readings. So that's something that's not really mentioned in the SparkFun Inventor's Kit Guide for the original circuit, and it's not really required for the coding challenge either. It's just something I'm going to incorporate. It's something when I've looked up this sensor via Google tutorials, as well as a Udemy course on Arduino that I watched. It was mentioned, and it's just a better way to do the coding for the sensor. So I'll show you that. Then I'll just go through the code in general, the Arduino code, starting with the setup of the pins and the serial communication. I'm going to ensure the RGB LED can be controlled through the pin assignments. And then I'm going to discuss the use of modular functions, such as trigger sensor for measuring distance, and handle LED color, which is a function that is going to be used for changing the LED colors based on predefined distances, thresholds. So again, if you've watched the videos before, I'm very big into separating complex programs into functions, sometimes even small functions that really encapsulate only a few lines of code. It just allows me to abstract code, so that way I can put a lot of functions in my loop, and that way you can kind of read my loop almost like pseudocode to explain what's happening, instead of just having everything all in the loop function. It just makes it hard to maintain the code and troubleshoot it. Finally, I'm going to talk about some dynamic menu system that I've created, that I've implemented with the serial monitor, that allows users to adjust LED distance time limits, toggle measurement units between centimeters and inches, and enable/disable an additional LED color. So in the original circuit, the LED will change between 3 different colors: red, yellow, and green, depending how far away from the ultrasonic sensor the object is. And as one of the coding challenges, we're going to enable a 4th color, so a blue LED. So again, all these things here in red are associated with the coding challenges. And then I'm going to address some troubleshooting points that I encountered, such as the need for the echo pin to be an interrupt pin, and on their Arduino Uno the interrupt pins are 2 and 3, and ensuring proper distance calculation using a moving average or a math complementary filter to stabilize readings. That way you don't have these large spikes where the LED changes color all of a sudden because you just had a erroneous reading that suddenly was said that it was like 3,000 meters away, which we know it's not. So we're going to emphasize in addition to that, we're going to emphasize the use of Boolean flags to control the visibility of the menu versus distance printing. So again, I'm using a serial monitor menu so that you can toggle between the different coding challenges. However, I just didn't like how there was lots of scrolling. I was constantly showing the measurement for distance, and the menu would only show for a second, and unless you were like really fast reader, that was the only way you were going to be able to see the menu. It still worked if you just typed the things, if you knew it, but that only worked for me or someone who's really familiar with the menu beforehand. So I basically just put in some Boolean flags to control the aesthetics of the program and to keep that menu still while the user is selecting something. And as always, I encourage you guys to make up your own circuits, fiddle around with this. If you want the code that I did, just message me on the forum and we'll do that. So this is really how I'm going to be going through it. I'm going to be walking through the code, first talking about probably the non-blocking Arduino program code, which uses interrupts instead of pulse in. Pulse in is a function associated with the how you would normally use the ultrasonic sensor. It's just an easier way to get going. The interrupt doesn't add much complexity, so it shouldn't be an issue. I'm also going to use Doxygen style comments as usual. I like Doxygen style comments because it allows you to comment your code as you normally would, but by adding like an extra asterisk or an extra // it allows you to put your code through an external program, in this case Doxygen, and generate some really nice professional looking HTML documentation to document your code properly. I'm also, again, still going to be talking about modular functions, breaking down the complex code into a lot of individual parts and functions to accomplish specific tasks. And we'll talk about the menu-based system and the serial monitor. And that way we can navigate through all the challenges. So the program overview, I'm going to be, again, really stressing interrupts to replace the pulse in function and have an interrupt-driven approach for distance measurement. Talk about the serial monitor and how it's used to select challenges. The coding challenges, RGB LED control and how we're going to change the color based on the distance, and we're going to do real-time unit conversion between inches and centimeters depending on if you like the metric system or not. And then I've got all the code copied into this PDF and highlighted it in a weird way that just will allow me to go through it quicker, as well as the troubleshooting I fell into, because I've been typically going through the Arduino code itself, but it's I'm just hoping this will be a little quicker. And if people don't like it, let me know in the forum. Although, to be honest, I'm not sure if people like any of these videos because they're long, and again, I am not a content creator. But we'll get back to the SparkFun guide and we'll start going through this. So I believe we're on page 60-ish, maybe. So yes, we've completed circuit 3A, which was our servo motor, if you followed the previous video. And now we're going to move on to the distance sensor. So, if you've followed any of my previous videos, I don't read the entire thing. I just kind of go through the highlights because I'm expecting you to kind of read this guide on your own. It's an excellent guide. It has great schematics, shows you how to build the circuit, goes through the coding. So I'm kind of just reiterating some things and just showing you a fellow student doing it. So, the distance sensors sense the presence of an object. So they can calculate speed and acceleration and avoid obstacles, which is great if you're dealing with robotics, which is probably something you want to do or you're interested in, otherwise you wouldn't be taking Comp 444. And the ultrasonic distance sensor measures distance using sound waves. So we have different distance sensors we can use, IR distance sensors and laser distance sensors, which use different technology. The ultrasonic distance sensor uses sound waves. This is what we'll be using today, an RGB LED, which, if you remember from previous videos or from your own experiments, it's just a single housing that houses 3 separate LEDs, a red, a green, and a blue. And there's a common ground lead, and then again you have leads for red, green, and blue. Because we're dealing with 3 separate LEDs, we need 3 separate 330 ohm resistors. Remember, you should never have an LED plugged in your circuit without a current limiting resistor, otherwise you're going to get possibly way too much current through the LED, which will mean it'll go really bright for a very short period of time and then possibly burn out. We're also using a distance sensor, and again, this is a fairly common and ubiquitous distance sensor found everywhere in a lot of Arduino projects, tutorials online. It's the HC-SR04. So if you've ordered any of those kits online, like I have, the 37-in-1 Arduino kits, this is what you'll get, and this is also what we got in the SparkFun Inventors kit that came with this course. And we'll need a bunch of jumper wires to attach things. So the new components that we're going to be talking about today are this ultrasonic distance sensor. So distance sensors work by sending pulses of light or sound from a transmitter and then timing how long it takes for those signals to bounce off an object and then return to a receiver, just like sonar. And again, it says sending pulses of light or sound. So again, that's because some sensors use infrared light and some use lasers. So in which case they'd be sending out light, whether you can see it or not. And then we're going to be using sound. So we're going to be sending pulses of sound because we're using the HC-SR04, which is included in your kit, and it uses ultrasonic sound. Sound that is so high-pitched that you can't hear it. And these are the 4 pins associated with it. You've got your 5-volt power pin, your ground pin, a trigger, and echo. We're going to be sending a pulse out through the trigger and receiving it via the echo. A new concept for us too, another one, is going to be data sheets, which contain all the relevant information, or data, needed for a particular part. And for example, it's going to contain the data sheet for this particular part, the HC-SR04, contains the calculation required to calculate the distance. So if you just click the link, you'll go to the data sheet. I've already got the data sheet, however, up. I've already went through the data sheet and did a couple highlights. Basically what it tells you is that this module, this ultrasonic ranging module, has a range of 2 centimeters to 400 centimeters. So if you're outside that range, if you're too close to the module, within 2 centimeters, or past 4 meters, you're not going to have reliable measurements. However, the ranging accuracy can reach 3 millimeters. The basic working principle of the ultrasonic sensor is there's an I/O trigger. You need to send out a trigger through the trigger pin for at least 10 microseconds, so sending out a high-level signal for at least 10 microseconds. And then the module will automatically send out 8 40 kilohertz pulses and then detect whether the pulse signal came back. And then we're going to use that to calculate the time from sending the ultrasonic pulse out to returning it. So that's how we're going to calculate the distance. So the test distance is calculated as follows. We're going to receive back a high-level signal. So the signal that we receive back in the echo pin is going to be a high signal for a duration of time that is proportional to the distance that was measured. So obviously you'll have a longer high-level signal, the longer the distance between the ultrasonic sensor and an object. We're going to take that high-level time, the duration that signal was high, and we're going to times it by the velocity of sound, which is estimated to be 340 meters per second, and then divide by 2. Why divide by 2? Because the high-level time is going to be proportional to the distance for the signal to go to the object, bounce back, and come back to the sensor. So it's going to be twice the actual distance because we had to come back. So that's why we divide by 2. And if you're curious how we got the velocity of sound to be 340 meters per second, well, that comes right from Google. If you Google, it's going to tell you the speed of sound in air at room temperature, around 20 degrees Celsius, is approximately 343 meters per second. So if you want to be really accurate, type in 343 meters per second, but this is right off the data sheet. They're using 340 meters. That's kind of a typical thing that's used. And to be honest, these sensors are only so accurate anyway that come in your kits, so that's going to be fine just using the 340. The wiring connections, as always, you're going to have a 5-volt supply line and a ground line. I shouldn't say as always, that's not always the case, but that's the lines that are going to power this module. And then you have your trigger pulse and your echo pulse connections. And then these are just some of the more information. It works off 5 volts, current 50 milliamps, working frequency 40 hertz. The range is again between 2 centimeters and 4 meters. Measure angle is 15 degrees. That's not that important, just basically says that obviously if you have something off to the side, the ultrasonic sensor is not going to pick it up. It's 15 degrees out from the sensor. So basically things that are in front of the sensor. Again, the trigger signal that you need to send out needs to be at least 10 microseconds long, and the echo signal, you're going to measure the signal that you get back, the high level signal, and that's going to be proportional to the range that the distance is. So from the ultrasonic sensor to the object that you bounced back off of and came back. This is just showing the unit itself. Again, you got your power pin, hook up to 5 volts in your microcontroller, your ground pin, hook up to the ground, and your trigger and echo pin. So the timing diagram works like this, which I'll just show you the timing diagram right here, and we'll just kind of zoom out for a minute. Okay, that's not going to work, so I'm just going to talk about the timing diagram and then come back to it, but that's the timing diagram. So you only need to supply a short 10 microsecond pulse to the trigger input to start the ranging. That's how you start the ultrasonic sensor to range and figure out the distance. And then the module will automatically send out 8 cycle bursts of ultrasound at 40 kilohertz and raise its echo. The echo is a distance object that its pulse width and the range is proportional. Again, the high signal that you're going to read back in through the echo pin, the width of that pulse, that high signal, is going to be proportional to the distance that the object was away. Now, you can calculate the range through the time interval between when you sent out the trigger signal, that 10 microsecond trigger signal, and when you receive the echo signal. So the formula to do that is you take that time interval, that's going to be in microseconds, and you divide by 58 if you want a measurement in centimeters. However, if you hate the metric system, you're still going to get the time interval, so that high signal is going to be a time interval in microseconds. You're going to divide it by 48, and that'll give you a measurement in inches, because, you know, inches just make so much more sense, I guess, right? I mean, 12 inches to a foot, you know, 5,280 feet to a mile. I mean, the numbers just make sense, as opposed to this crazy metric system where 100 centimeters, you know, to a meter, 1,000 meters to a kilometer. I mean, that's just crazy. But either way, whatever you're into. So again, the formula is the range equals the high level time, that the duration where your signal is high, times the velocity of the speed of sound, which is 340 meters per second, and divide by 2. And again, the reason we're dividing by 2 is because otherwise we'd be measuring the distance from our ultrasonic sensor to the object and back, because that's how it works. The signal has to bounce back. We need to divide by that 2 in order just to get the distance to the object. And it's suggested to use over 60 millisecond measuring cycle, so don't measure quicker than that. You can measure over that if you want a slower measurement, but don't do it quicker than 60 microseconds. So that was all part of the data sheet. A little side tangent there from the thing. We're also going to use if-else statements. And if-else statements basically allow you to, let me just increase this here, allow you to run one set of code when a logic statement is true, and another if it's false. So you can have a bunch of if, else, if statements, and only one of the codes will get executed, one of the statements. So we're going to use that to turn on the red LED of the RGB if the distance is less than 10 inches. If it's between 10 and 20 inches, we're going to turn on the yellow LED, and we're going to make the RGB LED turn green if it's, you know, past 20 inches. If you want to have 4 or 5 colors at different distances, you just add more else-if statements. That's all you do, and just output different colors. I added one more color for the coding challenge, but you could add as many as you want. In fact, you could make a fading color where you kind of go from, if you're really far away, magenta color, and as you get closer, you have a nice smooth transition backwards through Roy G. Biv, or through the colors, until you get to red. It's up to you. But more if-else statements if you want more colors. As usual, they have the guide has a very nice hookup table showing how to hook everything up. So again, the pins on your ultrasonic sensor are going to be 5-volt power, the VCC pin on one end, and the other is going to be ground, and then in between your trigger and echo pins. So trigger pin you want to set up as an input, echo pin as an output. It seems actually counterintuitive of me. So it should be your trigger pin is an output pin, because you need to send something through the trigger pin, and the echo pin is an input pin. So yeah, that just seems off to me. Guess I didn't notice it when I was reading the first time. But so again, we've got the VCC. Make sure you hook up the VCC to power and the ground to ground, and don't make that backwards. And just hook up your trigger and echo pin to what they have here. They have the trigger pin on a PWM pin 11 and the echo pin on pin 12. And then we have the RGB connected as usual, the common ground connected to ground, the ground rail, this breadboard, which is ultimately connected to ground of the microcontroller, just like the power is connected to 5 volts. And then you have each of your individual color LEDs, so red, green, and blue, all going through a 330 ohm current limiting resistor before being connected to pins 3, 5, and 6. So they are connected to PWM pins, pulse width modulation pins. And then that's kind of what it should look like there, so that you can move your hand or some flat object closer and further away from the ultrasonic sensor and light up the RGB LED accordingly. So again, this is the program overview. You're going to check the distance, check what distance the sensor is reading. If it's less than 10 inches, you're going to have a red light. Between 10 and 20, a yellow light. And if it's not equal to the first two conditions, meaning it's greater than 20, you're going to have a green light. This is just a little note. If you're in an area that has an HVAC system, air conditioning or something going on, or a bunch of other people working on ultrasonic sensors in your in your direction, you're going to get some weird readings. So these systems are known to somewhat affect the behavior of your ultrasonic sensor. So just keep that in mind. And so this is some code to note, but we'll talk about this after we go through the code. So I do have the original code up here. This is the code that you get right off the SparkFun Inventors Kit website. I'm just going to increase the size so you guys can see it better. And so we'll try to go through this quick because this video is already 20 minutes long. But as usual, they've got their multi-line comment at the start telling you what the program does. In this case, control the color of an RGB LED using an ultrasonic distance sensor, and you have links to the circuit diagram and the code. I've just commented out their constants for their trigger pin, echo pin, and the 3 LED colors, simply because I wanted to change them, but I wanted to know what the original one was. I could have just changed them in place because I needed to change the trigger pin and echo pin to pins 4 and 3. The reason being is because in my coding challenge, I have the echo pin on pin 3 because it's required, because pins 2 and 3 are interrupt pins and I'm using interrupts, whereas they have the LED on there. So I've changed a couple of the pins around, but besides that, the important thing is that the LED pins are all still on PWM pins. So 9, 10, and 11 are PWM pins, the same way 3, 5, and 6 were. I just had to move them around because I needed pin 3 for the echo pin, because I'm going to be using an interrupt. They've created a variable of type float, which is a new one for us. That's a floating point number or a decimal number. They've set that to 0. That's just going to store the distance. And in setup, we do the regular thing. We're going to set up serial connection, and we're going to set up all of our pins as inputs or outputs. The only input is going to be that echo pin, which is weird because, again, they have it showing as an output here for some reason, so I assume that's just a typo. But I think it was in the data sheet as well, so I'm not really sure what that, might have to look into that. But they have the echo pin as an output and the trigger pin as an input, which seems weird to me, given that the trigger pin is set up as an output because it's sending a pulse out for 10 microseconds, and the echo pin is an input because we need to receive something back. But either way, that's how that's set up, and all of our LEDs are set up as outputs. In the loop, we're going to call a getDistance function and store that distance that we get in the distance variable. And then we're just going to print that to the serial monitor, and it's going to be in inches. So I guess the measurement we're going to use is in inches, so we're going to be obviously dividing by 148. And so we're just going to put those at inches. And then here's our code that checks out, that determines what color the LED is. If the distance is less than or equal to 10, we're going to call the analog right a bunch of times, and we're going to call on the RED pin, we're going to have full color, 255, so full brightness, full color for the red LED, and 0 for the other two. So this will be a bright red color if we're less than 10 inches. If we're greater than 10 inches and less than 20 inches, then we're going to have full color on red and, a fifth of the color on green. So if we're outputting 50 on green and still none on blue, and this will give us a yellow color. And then finally, we're going to output full green if we're outside of either of these ranges, meaning if we're above 20. And then just a little 50 millisecond delay just so that we can read the code, the distance being put out on the serial monitor. And here's that function that returns the distance measured by the HC-SR04 distance sensor. So the function returns a float, doesn't take any parameters, but it does return a float, and it creates 2 local variables of type float for echo time and calculate distance. The echo time is a variable to store the time it takes for a ping to bounce off an object, and then the calculated distance is the variable to store the distance calculated from the echo time. Because remember, the echo time itself is actually calculating distance. It's calculating the duration of a pulse, which is proportional to the distance to go to the object and back. So the calculated distance will actually have factored in those calculations. So first and foremost, we need to send out an ultrasonic pulse that's it says milliseconds long, but that actually should be microseconds. That's just a little typo. So they're going to send the trigger pin high, and then they're going to delay for 10 microseconds. So again, that's microseconds that the trigger pin will be high, sending that high pulse, not milliseconds. That's just a typo they have. And then we're going to send the trigger pin low. So again, this code simply sends a 10 microsecond pulse, a high pulse, out through the trigger pin. And then the echo pin equals, we're going to call the pulse in function. The pulse in function, which takes two parameters. The first parameter being the pin that you want, that the echo pin that you want to read in on, the echo pin should be connected to, and high. So high just indicates the mode that this sensor works in. We can't change that. Some sensors work on low mode, but not the HCSR04. It works on high, so you just have to put high in here. So this is how the pulse in function works. You just put in the pin, or the variable constant representing the pin, that the echo pin is connected to on your microcontroller, and put high in because this ultrasonic sensor requires that. And ultimately, we're going to assign that to a variable called echo time. So again, this uses the pulse in command to see how long it takes for the pulse to bounce back to the sensor. But again, that's the time to go to an object and bounce back. The calculated distance, this is something we've seen in the datasheet, takes the echo time and divides it by 148. Why 148? Because that gives us the distance in inches, which is what this code has decided to do. They obviously hate the metric system. And then we're going to return that calculated distance. So that's what this code does. We're going to upload that to our Arduino board. Make sure the right COM port, Uno is selected. Okay. So it's just uploading now. Still uploading and done uploading. So the code is uploaded, and we're getting weird messaging. Oh, and I see what it is, so I'm going to just get the code a little smaller here. So we're getting that weird messaging because this code has the baud rate at 9600, and for whatever reason I have it at 115,200. So we'll change the baud rate, and there you go. You should be seeing some measurements there. We're about 90 inches from something. So if I take anything, in this case a cardboard box, and I put it here, I'm outside of 20 inches. You can see it's it's measuring about 22 inches. So the LED is green. If I move with closer than 20 inches, it's going to turn yellow. So now it turns yellow. And then if I keep moving, and if I get in within 10 inches, we know it's going to turn red. So I'm at 11 inches. I'm at 10 and some, 10 and some, 10 and some. Still just 10 point something. And then now I'm at 9 inches and some. So I'm in red. And I'll remain in red as I keep moving this box closer. And then when I get outside of 10, right here, wait, I'll get stuck. So, correction, I'm within 10. And then outside of 10, I'm in yellow. And if I keep going outside, when I get outside of 20, I turn green, and then it just stays green. But that's basically how it works. If you're within 10 inches, you're red. If you're within, like I'm between 10 and 20 inches, so right now 12 inches, I'm yellow. And if I'm outside of any of that, meaning greater than 20 inches, the code turns green, the light turns green. So that's the simple code. But that's not what we're here for. We're here for the coding challenge, and we're already half an hour in, so let's get to it. So the coding challenge is this. First, I'm just going to upload this code. As you can see, even though this code's not uploaded, the serial monitor is still working, and we're still measuring 90. And this is the coding challenge code I have, which is just a lot more code. And I'm going to upload that. So first things first, I'm going to upload that, and we'll just see it working, and then we'll talk about what it's doing. And now I'm having weird things again. Why? Because I think in my code I have the baud rate for serial.begin at 115,200, which means I need to bring that back. Just reset that. So I just reset the LED. So now I have the coding challenge code done up. And so what my code does is it first of all prompts you with a message. Choose your coding challenge adventure. You can use, you can change the LED distance limits, which is one of the coding challenges. You can toggle the units from centimeters to inches. You can enable a fourth color. That's that blue LED will come into the mix. Disable that fourth color if you don't want it, or just display the distance reading as is, default. So let's just start off by just clicking 5. I'm just going to display the distance readings as default. So now it's essentially doing what it did before. We've seen that, you know, the door that is in this room is 90 inches from the wall, and it's green. And just as before, if I come within, if I'm outside of 20 inches, right now I'm at 22 inches with this box, it's still green, but when I come within 20 inches, between 10 and 20, I'm yellow, and as I move closer and closer, and with just before, I'm at 10.31, but as soon as I move beyond 10, within 10 rather, I'll turn red, and it turns red. So when I'm in default mode, the code works the exact same way that the original circuit worked. However, if I want to see the menu again, I can just press M on the keyboard, and it'll pause the scrolling and bring up the code again, and I can do something else. I can change the LED distances. So let's press option 1, and then it's going to ask me to just enter 3 distances separated by space. So I'm going to do 5, 10, and 17 for some reason. And so now the colors are still going to be red when you're close, yellow when you're a little further away, and green, but the distances aren't 10 and 20 now. They're 5. I'll be red within 5 centimeters, or 5 inches rather. So I'm at I'm at 4, still red, and as soon as I go past 5 inches, you see how I turn yellow. And then if I keep going with my hand, which I just realized you guys can't see because I have the screen up, but when I get outside of 10 inches, I turn green, and then I'm just green. So I basically have just limited this, or I've just shortened the range on this quite a bit. So again, within 5, it's red. As soon as I pass 5, it will turn yellow this time. And then when I'm past 10, it turns green. So that was just changing the limits. I can press menu again and change them back. So again, I'll choose 1 again, and I'll go 10, 20, and I guess that's all, 30. 30 is not really required, but so 10 inches, and then it changes, and then after 20 it turns green, and the 30 isn't required for this. The reason I enter 3 colors is for, if I press M again, if I enable a 4th color. So that's what I'm going to do. I'm going to enable a 4th color by pressing 3, and now blue is one of the options. So now the furthest range is blue, so that 30 actually comes into place now. 30 inches for blue. So if I'm outside 30 inches, I'm blue. As soon as I come within 30 inches, I'm green, and then all the other ranges come into play, so yellow and red. So that turning green, that's just more or less, I can't fit this big box, the thing I was using instead of my hand, past some of the setup I have here. So I'll try to get something else. So again, the ranges are still going to be 10, 20, and 30 now comes into play with blue. So So 10, I turn yellow, and then when I get past 20, I turn green, and then when I move it completely, it turns blue. I've got way too much stuff on the desk here to be doing this properly, but that's so I've added a fourth color. I can press M again to bring the menu back, and now disable the fourth color. So I'm going to click 4, disable the fourth color. Now it's green distance, but you know what? I'm going to re-enable it because I like the fourth color. So you notice I didn't have to bring the menu back that time. I'm disabling. Look, I'm pressing 4, disable, pressing 3, enable. Because I'm aware of what the menu options are, I can just click them. I actually don't have to press M and see the menu. But really, if you press M, you'll see the menu and see what's going on. And 2, I didn't try 2 yet. 2 is just going to toggle. Right now, you can see that I'm showing everything in inches. If I toggle, it's now centimeters. You can see the numbers change because 90 inches corresponds to like 231 centimeters. And again, because I know that toggle is 2, I don't have to click back the menu. I can just press 2 over and over on the keyboard and switch between inches and centimeters and inches and centimeters all day. Okay, so that is the demonstration of the coding challenges that we completed. But let's go look at how we accomplished that. So again, we're going to go to the coding challenges and read what's happening there. First, before we do that, we'll just note the code that is happening so far anyway, before even the coding challenges. We're using floating variables now that we haven't used before. Basically, it's a floating point number. Instead of using integers, it's a way to represent numbers that have decimal points. The values are just, we can just have more precise values than an integer. So we can measure precise distances, such as 9.33 inches instead of just 9 inches, which is why if we look at our code, our value is 9.7 some inches. We've got decimal representation. We just use if-else statements. Else-if statements combine more than one logic statement, whereas an if statement just checks if something is true or not. And so if it's true, you execute the code in the if statement. If it's not, you don't. Whereas then you can use if-else statement to just, hey, do this. If this is true, else do this. Well, using if, else statements, they allow you to select one option out of any multiple number of options. So only one of the options will be true, and then you'll skip all the other sections. So which makes sense, because in this case, we're using the if, else statements to make the RGB LED turn red, yellow, or green, depending on the distance that an object is from the sensor. And we only ever want one of these things to happen. So that's how an else if statement works. And then we've created lots of user-defined functions in this, both in their original code, and then we've also further did that in the coding challenge. So this is the coding challenge. Again, we want to change the limits of the distance sensor, so try editing the values in the logic statements so that the RGB LED changes color at different distances. And that's what we did there when we selected number one option, change LED distance limits, because when I clicked that, then it told me, hey, enter 3 distances separated by spaces. So I did that, and I changed it to like 5 and 10 and 20. And then that affected, now the red happened at, I guess I don't have the, that the red happened when we were within 5, but as soon as I was out of 5 inches, then I turned yellow. And then when I was outside of 10 inches, green, and then outside of 20, I turned blue. My apologies. So that's one of the coding challenges completed. The other one was change the units of the distance sensor. So try editing the code so that the distance is output in a different unit of length. And that's when we toggled, again, when we did option number 2, toggle the distance units, centimeters to inches. So if I click number 2, I'm in inches right now, but if I enter 2, it's in centimeters, and I can keep toggling with 2 back and forth between inches and centimeters. And the fourth challenge was to add that fourth color. Try adding another else if statement so that there are 4 colors. And again, that's what we did when we, why we have a blue LED right now. So if I disable fourth color 4, you'll notice the LED turns green for long distance now because I have nothing in front of this, it's just going to the door. But if I enable it, go 3, I enable the fourth color. Now we've got 4 colors for our distance, and the longest is 4th. And I can keep going. You know, I could disable it, enable it, disable it, enable it, and so forth. So that's the coding challenges. And then we're just going to go to that. So instead of going through this code, which is the exact same thing, I just copied it and put it in my circuit here so I can go through that. So what I'll do, if you're really interested in seeing the code, you know, that's not all messy and highlighted and weird, and you'd rather follow through this, just let me know, and I can post a separate video of me just starting and going through this code in the Arduino IDE, which might be easier for people to follow. But in this case, I'm going to try this, and I'm going to try going through the code that I've copied into this Word document, well, the PDF now, and I'm going to go through this way. So basically, as usual, the code starts off with a multi-line comment, but in particular, a doxygen comment. So I've got this extra asterisk and these tags, which basically, again, just allow me to create some nice professional-looking documentation from this code if I want to. And this program is going to allow the user to change the behavior of the program, i.e. affect and activate the coding challenges through the serial monitor menu system. And that's going to be a dynamic setting that you can just type in anytime. I'm going to be talking about using interrupts instead of the pulse in function that we see in the original circuit, so that we can have non-blocking distance measuring, meaning code that's not going to stop the execution of the program. So that's what this is going to do. And actually, before I go through the Arduino, I understand this is a long video, but this is very thorough. It's going to be in detail. So if you really want to know about the HC SR04 ultrasonic sensor, and then you can watch this video in its entirety. Otherwise, just skip through parts that are more pertinent. But I am going to just quickly show the notes for it. These are a couple notes I have up on the ultrasonic sensor. So these are notes from a Udemy video, so a Udemy course that I purchased that taught about Arduino. So I watched a lot of their videos, and it basically, a couple of the notes here. Again, this sensor measures distances. It's got a range of 2 centimeters to 400 centimeters, 15-degree angle, measuring angle, measures distances. So it's got an active sensor. The trigger pulse needs to output for 10 microseconds. The echo pin, which is normally low, will send a high pulse to the Arduino. That high pulse for a certain amount of time, which again is proportional to the distance that the object is in front of the sensor. And in this code, we're going to attach the echo pin to an interrupt pin. That's digital pins 2 or 3 on the Arduino Uno. And why we can do that? Well, we could just use the pulse in function in high mode, because that's what our sensor requires, to return the on sign long, indicating the duration of the high pulse, so how long this high pulse is on. We could use that. That's what we did in the first circuit before the coding challenges. But the pulse in function has the same detrimental effects as delay does. So you might remember in some videos I was talking about how we keep using the delay function as a button debounce in some of our programs, which is simple, and for the simple projects we've worked with, works just fine. It's quite adequate. However, a better option to implement delay functions, button debounces, is to use time functionality instead of delays. And I've talked about that previously, so I won't get into too much here. We'll kind of end up going through it a little bit when we talk about this interrupt stuff that we're going to do in the code. But basically, using time functionality and interrupts just works better than using delays. So the pulse in function has the same detrimental effects as just using delay as a debounce instead of time functionality. So that's why there's a better option out there. We're going to use time functionality and interrupts instead of the pulse in function. I understand that was kind of a lot of word salad there, and hopefully when I show you the code, it'll be clear. And again, this is just how we calculate the distance. We've already talked about this. We take the duration of that high pulse, whatever we read in, and we times it by the speed of sound, divide by 2. Why divide by 2? Again, because the duration is measuring the time it took to go from the ultrasonic sensor, hit an object, and bounce back. Again, if you want to be really accurate, the speed of sound is 343 meters per second, but really 340 will be fine. And why am I doing this whole 0.0343 centimeters per microsecond? Well, it's because the speed of sound is in meters per second, but our duration is measured in microseconds, and we want to output centimeters, so we need a value in centimeters per microseconds. And when you do that dimensional analysis, this is what you get. and then we times by 1/2. That's the same as dividing by 2. That'll give you ultimately something like this: duration times this number, or duration divide by 58.309, or by 149 if you're in inches. This is the inch. So again, this is really what it is. Again, if you're wondering how I got this number in the first place, it's down here. I took 343 meters per second, which is just the really accurate speed of sound, according to Google. You could just do 340, and that would be fine. But 343 meters per second, you do some dimensional analysis by timesing it by 100 centimeters per meter, so the meters cancel out. And now you've got centimeters per second. And then you do some more dimensional analysis to get rid of seconds, so you times it by 1 second per 1 million microseconds to get this number. So that's how I got that. And then we're also going to use a complementary filter, which is a mathematical filter, to smooth out spikes. Basically, it's a software fix to a hardware problem. These aren't the best sensors, and so that's something we're going to do. So that talks about that. Maybe I'm just going to quickly show the screen, and I'll quickly go through that this calculation in detail for anyone who's, it's been a little bit since they've been to the math class or whatever. I have a child in high school that I help with their math homework a fair bit, so hopefully I'll be able to show something here. Actually, you know what? That's not going to work. I was going to try to do a split screen, but that will just make it so that you guys can't see. So just bear with me a second. I'll get back to where we were. No split screen. Let's just do it this way. So we're basically, the calculation for distance, again, we calculate the distance by measuring that duration, which is that high pulse that we receive in on the echo pin. Just move this out of the way because it's probably distracting. So distance equals the duration times by the speed of sound, which is then divided by 2. And again, why are we dividing by 2? Because the duration of that high pulse that we receive is from the sensor to the object, some object, and then back. So we need to divide by 2 in order to only count the distance to the object. So that's going to equal the distance, just d for distance, equals that duration times, in this case we did 343 meters per second. You could just do 340. Either one's fine. I'll just do 340 in this case because that's a simpler thing. 340 meters per second. And then, that's the speed of sound. And then divide by 2, or in this case, let's times it by half, which is the same as dividing by 2. But I don't want meters per second. So I need to do dimensional analysis to get this to something that's more relatable. Because duration, this is measured in microseconds. So we need the time in microseconds. And we know that we're outputting distance in centimeters. So what we'll do is we'll go 340 meters per second times by, do dimensional analysis, there's 100 centimeters in 1 meter. So now the meters cancel out. And so this gives us a value of 340 times 100. Well, that's going to be 34000. And that's going to be centimeters per second, which I'm running out of room. But that'd be centimeters per second. So then we have that, 340,000 centimeters per second. Just need a cough drop for a second. And then we need to get rid of the seconds. We want that microseconds, so we're going to times that by something with seconds in the numerator to cancel, and microseconds. And there's one. We know that there's 1,000 milliseconds per second, and there's 1,000 milliseconds per microsecond. So there's 1 million microseconds per second. The seconds cancel out, and we basically take this number, obviously, and divide by a million. That's what's happening there. And that'll give us, well, let's just, so if we take that and divide by a million, we get 0.34. It's like gonna actually verify because I think I was off over here. Let me just verify. If I have 340 meters per second originally, and I times it by 100 second, there's 100 centimeters per meter, so times that by 100, 34,000, and then divide by 1 million. Okay, there we go. We get 0.034 now centimeters per microsecond. So that's what we have now per microsecond. But then we have to times that by half or divide by 2, whatever you want to do. We'll just divide by 2 there. So if I divide this by 2, I get this number, 0.017. Again, that's centimeters per microsecond. And then, so I need to take this number now is what I need to times the duration by. So I need to go duration times by this number. Because again, I was originally just timesing by the speed of sound, divide by 2 or times half, but it was in meters per second. This number now represents the speed of sound that's already been divided by 2, but it's in centimeters per microsecond. But sometimes instead of timesing by this, we could times by this, or we could just divide by the reciprocal. So anyone remembers, how to divide by a fraction. If I have some number, let's say 7, divide by half. Well, dividing by a fraction is often difficult, so we used to just say, well, instead of doing this, just take 7 and times it by the reciprocal of this, which is just flip this things upside down, so it becomes 14. Okay, the same is true if I was timesing by 2 in the first place. I could divide by the reciprocal. So instead of timesing by this, we could divide duration by the reciprocal, which is 1 over this number, and that'll give us the same thing. So what is the reciprocal of this? Well, there's this fancy little reciprocal button here, so if I press this, it's 58 and change. So basically I need to take duration and divide it by 58 point something, blah, 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 blah. And again, some of my rounding might be off, but that's where we get that 58. So then if we go back, that's why we divide, to find our calculation, we divide by 58. And again, there's some change here in this calculation, but this is based off 3.43 meters, 340. The rounding doesn't matter. 58 is a number that in the data sheet that we divide by for centimeters. And then again, the same calculation would hold true if we were doing inches. I just wouldn't have converted meters to, I would have had to convert to inches. So that'd be just longer video than we already need to be already, so we just won't do that. So that's how we got there. Why are we sidetracking? I can't remember why. Okay, so that's a quick little sidetrack of where this calculation came from. So again, I'll try to be a little quicker now going through the video. Basically, we have our pins set up. Again, trigger pin is 4. The important pin is echo pin is on pin 3. It's the interrupt pin. We need that because we're using an interrupt for instead of pulse in. We have our red, green, and blue LEDs on pulse width modulation pins, 9, 10, 11. This code here is used to help control the speed at which we trigger. We want to trigger every 60 milliseconds. Again, if you remember the data sheet, that's what they kind of recommend. Use at least 60 milliseconds or over 60 millisecond cycles, so that's what we're doing. We're using 60. I could change that to 100. It'd be a little slower, but it'd probably be fine. We're probably still not going to run into anything with our robot. But again, This is all for helping time. This is using the millis thing, which returns the time since the Arduino turned on, this function. And we just assign it to an unsigned long because it returns a millisecond. And it's the last time the ultrasonic sensor was triggered. And then we want to trigger, this is our duration, the delay. We want to trigger every millisecond. So this is going to be used, this is time functionality used to trigger every so often instead of using a delay. Then we're creating a one-dimensional array type float for our distances. These are going to hold the 3 distance values that are going to control what LEDs turn what colors. So these are user-defined limits for the RGB control. Again, in the original circuit, we really only have 2 limits. The third limit is for use when we add that 4th color. This is just a Boolean variable I'm using to toggle whether I'm outputting in centimeters or inches. That's so that we can have that dynamic control, changing our unit. And then the show menu flag. These 2 Booleans are just used to, this will allow me to stop the serial monitor and show the menu and stop scrolling. That's what that does. And this is just whether or not I have enabled that second LED, that 4th LED, the blue one. These are the variables for the non-blocking interrupt functionality. So again, I'm using pulse start time. These are all unsigned longs. Pulse start time, pulse end time. I'm going to use these to create a duration, which is what the pulse in function does. But I'm going to use basic time functionality to do it. And this is going to be a Boolean variable that says, was the pulse received? They're all marked volatile, the keyword volatile in front. Whenever you're modifying something inside of an interrupt function, you need to preface it with the keyword volatile. If I wasn't modifying these things and I was just using them, I wouldn't need the volatile. But because I'm modifying these variables inside of an interrupt function, I need this volatile keyword. And this code is associated with that math complementary filter. So basically a filter just so we don't get huge spikes in our readings. So just double previous distance. I'll explain that as we get along, but 400 basically means sometimes you get, with these sensors, you get like a reading all of a sudden, a spike that's like says the object is 3,000 meters away or something ridiculous. And we know that's not possible. First of all, the sensor is only accurate within 400 meters, so anything outside of that is just a weird error, but will cause weird things in our code, depending on what the ultrasonic sensor is controlling. In this case, it's just an RGB LED, so the light will just turn a different color for a minute, but it's still an undesirable effect. So in this case, we're using a filter, a software fix to a hardware problem in order to help limit that. So we're just basically saying that we can never have more than 400 as a distance. That's kind of what this does. I'll explain it more when we get down there. In setup, we set up serial communication, 9600 baud rate. I think I've changed that a few times, depending. Set up all my pin modes. Again, everything is output. The trigger pin is output because it's sending the 10 microsecond pulse, and all the LEDs are output, and the input is your echo pin. And then here's the setup for the interrupt. We call the attach interrupt function, passing in 3 arguments. The first argument being another function call, digital pin to interrupt, and just pass in the pin that you want to interrupt, and the echo pin in this case, which is pin 3 on the Arduino. Pins 2 and 3 are interrupt pins. And then we call we pass in a function that we want to execute when there's a change to the echo pin. And that's indicated by this. We could do it when it's low, high, different things. Whenever there's a change, we want to have the interrupt execute this code. And you'll notice that you don't put the parenthesis. Okay, so this is a function, but you don't put the parenthesis in this argument. It's just a weird thing. And then I'm calling this show menu. When I first start the program, we call the show menu once. So I'm going to press reset on the Arduino microcontroller, which will reset the program. And you'll see when I first call the program, it shows the show menu. That's all that's saying. And then in loop, I always get the current time, the system time, by calling the millisecond function, assigned to time now. And this allows me to do all that stuff when I can trigger. So remember I said that this stuff highlighted in green was, instead of using delays, I'm using time functionality to trigger every 60 milliseconds, instead of just using a delay, which basically means that my code is not functioning for 60 milliseconds every loop. I don't want that. So instead, I'm going to get the time every time I enter the loop, and I'm going to go if time now, which is the time I just read, minus the last time the ultrasonic trigger happened, if that time is greater than the ultrasonic trigger delay, and that ultrasonic trigger delay I've decided to be 60, because as per the data sheet, I could have made it greater than that, 100 or something, but 60 seems to work. But you don't want to go faster than that. So if the time now minus the last time that I triggered the ultrasonic sensor, if that's greater than 60 milliseconds, this delay, then first of all I'm going to update the last time the ultrasonic trigger to now. So I'm going to update it by going plus equals the ultrasonic trigger delay. So basically I'm adding 60 milliseconds to the last time the trigger was, so now the next time I come in, it'll be 60 seconds later. And so this code basically is just a way to continually allow me to wait 60 milliseconds before outputting another trigger pulse. It just allows me to do it without using delay function. I could just obviously have, use a delay function every time in the code, but that wouldn't be, my code would be not working for 60 milliseconds every loop. This allows the code to continually work using time functionality. A little more complicated, but once you've got it written in there, you're good to go. And then we call the trigger sensor, which is a function that just basically sends a 10 microsecond pulse out high, which will go right here because it's right here now. So again, it just, first of all, we write the trigger pin low for a second. For how long? Well, 2 microsecond delay. So delay microseconds, and we pass in 2. And then write it high for 10 microseconds. Now, if you followed, and then we write it low again. Now, if you followed me before, I think I've mentioned before that you don't really want to use delays in first of all, in the code in general, I said you don't want to use a delay because then the sensor's not working for that period of time. And especially in interrupts, you can't really use delays. But so why are we using it here? Well, there's a couple exceptions. It's fine using a delay in setup because the setup only runs once, and then you can use it to set things up. That's fine. And because these delays are so short, I'm using a delay of 2 microseconds and then a delay of 10 microseconds. I mean, that's 12 microseconds out of however long this code is running, like how long it takes to loop. It's going to represent less than 1% of a percent. So it's fine. And why am I writing the code low? I thought I'd have to write a pulse high. Well, it's because when I come into the trigger sensor, I don't know what the signal was on the trigger pin. Was it already higher and stuff? So by writing it low for 2 microseconds, I assure, and then writing it high, I assure that I have a high pulse for 10 microseconds. And then I write it low again. So it's just a way to ensure that I absolutely am writing a high pulse for 10 microseconds. And then so that's what we're doing here. And then if pulse received, so if we received a pulse, and that's going to be a Boolean flag that toggles. If we did get a pulse received, first of all, I'm going to reset the Boolean flag to false. And then I'm going to call the calculate distance function and assign that distance to this variable. That variable is then going to go into the handle LED color function, and then it's obviously going to change the color of the LEDs based on the distance. So I'm abstracting away a lot of the code into functions. This is doing modular coding by using a calculate distance function and then sending that to this distance variable. Using that distance now that I got from the calculate distance function that was returned from that, I'm passing it to this handle LED color function. And again, all the code's being abstracted away from me. I could put all this detail here in this loop, but it'd be really hard to read, whereas now I know what's happening. I'm calculating the distance, and then I'm using that distance to handle what LED color turns on. It's it's easy to read. And then I'm going to go if not show menu flag. So this is a Boolean variable I'm using to control whether or not I show the menu on the, like right now there's a menu showing, and if I just go, and it's not scrolling. So this variable just controls whether or not I show the menu on the serial monitor or not, because obviously most of the time it's not being shown. So if show menu is false, meaning it's not showing the menu, and not false is true. So if showing the menu is false, we're not showing the menu, then I want to print the distance. So basically, if you're not showing the menu, I want to be outputting the distance, which is what's happening. I'm not showing the menu, I'm outputting the distance. And again, I've extracted the code away by calling a print distance function and passing distance in. Else, meaning if this wasn't the case, and we actually do want to show the menu, because this Boolean variable is true, well then I'm going to call the show menu function, and I'm actually going to show the menu. And then finally, the last part of the if statement is I'm going to handle the user input from the menu navigation. So when the menu is showing, or even if it's not, and they just type in the right command, 1 to 5, whatever command they want, or M as well, If serial.available is greater than 0, meaning if they've typed something in and press enter, then I'm going to do a single read using the read function, reading a character at a time. I'm going to read in that character, which is going to be the character the ASCII code for 1, 2, 3, 4, 5, or the character M. And then I'm going to call a handle menu selection function, passing in choice. So basically, if the users type something in the serial monitor, that's what this line does. I'm going to, if there's something available to read because they've typed something in the serial monitor, I'm going to read it in a single char, and I'm going to pass that char into a function, handle menu selection. Again, I've got, like in this short, this is this is the entire code of loop. So from there to here. Okay, this is the ending breaks of loop and up here. And all I'm doing in loop, again, let's get that on one screen. This is loop right here. All I'm doing is I'm using some time functionality to send out a trigger pulse every 60 seconds based on, if the time now that I read as soon as I jump in the loop, if it's greater than the last time I sent out the trigger, if that duration is greater than whatever I've decided as the trigger delay, which is 60 milliseconds as per the sheet, I'm going to update the last time I sent out the pulse to, I'm going to increment it by 60 milliseconds, the delay I want, and I'm going to send the trigger out again. I'm going to do this every 60 seconds. That's what that code's doing. And then if a pulse is received, I'm going to reset the Boolean variable so I only receive this every 60 seconds, because that's what's happening in the trigger sensor function. So every 60 milliseconds, I'm going to do this. I'm going to calculate the distance, and I'm going to use that distance to handle what LED color turns on. And this is just so I can have serial monitor menus and I can dynamically change the code, this if-else statement. Basically, if I'm not showing the menu, then I want to be showing the distance by passing the distance to this function, print distance. Otherwise, I want to show the menu. And then depending what you type in, what the user types in, based on the menu selection, I'm going to read that in and use that to do something, handle menu selection. But look at all the different code functions I have to abstract away the details of the code. Trigger sensor function, calculate distance function, handle LED color, print distance, show menu, handle menu selection. And I also have other code, other functions that aren't seen here because they're helper functions that are being called by other functions. But anyway, we already went over the trigger sensor function. This is the echo handler function. So when we read that in, read that high pulse duration in. Well, this is what we do to handle it. We go, the echo handler function takes no parameters, returns nothing. And I'm just going to make this big again. It simply says, hey, if digital read of the echo pin, so digital pin 3, if we read a high signal, meaning we're getting a measurement, that high signal, indicating that the distance the object is from us. If that's true, then we're going to call the micros function, which is just like the millisecond function. It returns the current time, but instead of in milliseconds, it obviously returns it in microseconds. This is just done to be a little more accurate. We could use milliseconds here, but this is just going to be a little more accurate, a little faster. So we're going to call that function, assign it to pulse start time, which is one of our time functionality variables. It's an unsigned long. We're going to assign it to pulse start time because again, as soon as we read high, well, that's when we want to start seeing how long that pulse is high. Because again, that represents the duration that the pulse is high is ultimately going to be used in the calculation of the distance. So as soon as we read high, we're going to come in and call the microsecond, which is going to return a value of microseconds since the Arduino program started. We're going to assign that to this variable, pulse start time. Else, meaning as soon as it's not high, once it's low, we're going to call micros function again, pass it to pulse end time. So now we basically, when the pulse was high, when we were reading high on the echo pin, we found out what the time was in microseconds. And then when it stopped being high, we found out the time in microseconds and assigned it to end time variable. And then we're also going to toggle this Boolean flag, pulse received true. Basically, hey, we just received a pulse, and we're going to go back to the loop and say, hey, we received a pulse. If pulse received, we're going to do all this. We're going to calculate the distance, change the LED color, and blah, blah, blah. A bunch of other stuff. So that's what the echo handler does. It basically just reads the thing high, and then see we've assigned a couple of variables so that we can then find out the duration at the time that it was high. Where are we going to use that? Well, we might use it soon. Probably right now, because we're going to calculate the distance. So this function calculates the distance and returns a float. You could have used a float, a double, doesn't really matter. for the numbers, the size of numbers we're going to be using. So now we're creating a local variable unsigned long duration. Well, what's the duration? It's equal to the pulse end time minus the pulse start time. That's the time, how long the echo pin was reading a high signal. So we're going to minus the start time from the end time, and that's going to give us the duration that we had that high signal. Then we're going to use that duration in our distance formula. So again, we're creating a local variable, float distance. It equals, I'm going to skip this for a second, but basically it equals the duration divided by 58, if you want to know it in centimeters, or the duration, which again is that the duration is the time the pulse was high. We read on the echo pin. We're going to take that duration divided by 148 to output in inches. So what are we doing here? Well, I've shown this in a couple of videos. This is a tertiary operator. Basically, in one line, in a very compact one line of code, it allows you to do an if-else statement. Basically, the distance is going to be if the used centimeter, if this Boolean variable, this is a Boolean variable, I don't know if you remember that we have up here at the top, Boolean used centimeter, false. This controls the unit, whether we're in inches or centimeters, inches by default. It starts off false, but if that is true, then we're going to execute the code that's after this question mark. So if true, we're going to do this, which is we're going to take the duration that we just calculated and divide by 58. And that'll give us a distance in centimeters. But if it's false, meaning if this used centimeters is false, which it by default starts off false, we're going to output a distance in inches by going duration divided by 148. That's what that's doing. This, and then really if we didn't want to do, if we wanted to calculate that distance, we could just return the distance. That would be easy. We could do that. This extra code highlighted in blue and yellow and white here, this is just extra code that's not really necessary, but it will make it will give us a filter so that our readings will be better. And to actually truly show that, I know this video is quite long, but I'm gonna quickly show that because I think that will be worth it. Again, if you're watching the video this long so far anyway, hopefully it's because you really are interested in this sensor and all the fun stuff you can do with it and you really want to know about it. So I'm just going to pull this up. So this is the original code in case the computer's doing something weird here. But this is the original code. Come on. And I'm just going to re-upload this to the so I'm going to upload this to the board. Okay, Raycom port and all that's selected. All over the place here. Let's just throw it on that side. So right now, this is the original code. And I've got the wrong baud rate again. So this is the original code. And we're going to pull up the serial plotter. If you go up here, right next to the serial monitor, there's this little thing called serial plotter. And I'm going to put that right there. And so that's showing the signal, what is being read. So again, the distance is, around 80. We know it's around 90, but do you see how we're getting these big spikes? So, and nothing's happening. I'm not moving in front of it, and we're still getting spikes just because of the sensor. It's not that great, and we get these spikes, and so the distance is constantly fluctuating. It's not really affecting the light at this point. The light is, for the most part, just staying green or whatever, and if I move my hand, it'll probably, you can see now I'm very close. But even then, I'm not moving my hand, and there's still, the distance is now lower. See, it's a lot lower, but see how we still get these big spikes? So that's what's happening. So the filter is to help with that, take that away. So I'm going to go back to this code. So this is my coding challenge, and we're going to now upload this code. So again, this is the messy serial monitor from the original code. Once this code loads up in a second, I'll be able to show this. Uploading. Okay, and we're just going to show the distance. We're not going to do anything fancy. We got to bring this back to the right baud rate. So we're outputting the distance, but again, I want to show you the serial monitor, the serial plotter. Okay, come on, let's run this. Okay, just 1 second. Not sure why the serial plotter's deciding not to work. Let's try it again. So when I pull up the serial plotter with the old version, okay, if it doesn't work in a second, but you've seen how messy was that? I'm not sure why the serial plotter doesn't seem to want to work this time. I'm going to change the baud rate to 9600 and see if that makes a difference. Going to go all the way up to the setup menu. We're going to change this to 9600. Maybe the serial plotter is iffy at more than this. It shouldn't be, but 9600. Oh, I know what's happening. I just the baud rate changed when I uploaded it, so but I didn't change the program. I think that's what's happening here. So we'll re-upload with 9600 baud rate. We'll open the serial plotter up, and hopefully we're good to go. So. I think maybe something else that because I'm using weights and stuff, maybe that's affecting it. So it would be easier to actually just put the code in another time. Maybe I'll upload a separate video showing on this simple code when you put a filter in and use interrupts, how much smoother it makes. But basically what it does is it makes your code a lot smoother, so it makes it so you don't have those spikes. And there's some trade-off between delay and stuff, but I'll talk about that after. But anyway, we'll get back to the code because we're tangenting quite a bit, and I apologize for that. But basically what the math complement filter does, it says if the distance is greater than 400, automatically we're going to return the previous distance. Because if it's greater than 400, it's an error anyway, because the range of these sensors are only good up to 4 meters anyway, 400 centimeters. So if it's greater than that, it's an error anyway. So if it's saying 3000, we know that's inaccurate. So when I first start the program, we had the previous distance set as 400. For the reason if we right away get a value that's above that, well, we're going to ignore it. And we're just going to set anything above that value to the previous distance. So the first time it would be 400. After that, it'll be whatever the previous distance is. And then we're going to go distance equals previous distance times 0.7 plus distance times 0.3. Now these numbers, the only thing that really matters is they add up to 1. So 0.7 and 0.3 adds up to 1.0, so 1. Now what you're doing here, the basic premise is you're taking the average of the previous distance and the new distance and averaging out. That way if you get some weird spike, it won't be as much because you'll have averaged it out. Now if you wanted it perfectly average, you would do 0.5 and 0.5, which would be fine because they would add up to 1 still. But with fiddling around, I found 0.7 and 0.3 happen to be kind of the best values. So if you do 0.9 for previous and 0.1 for distance, you'll get a very smooth response to your curve. You won't have any spikes. It'll be really smooth, but it'll be a slower response, which may matter depending how fast your robot goes that is using this ultrasonic sensor. You might have a really smooth transition, no spikes or anything, but you're a slower response, and if your robot's going fairly quick, it runs into a wall. On the other hand, the more you have these even, where you're averaging out the previous distance and the current distance, and they're closer to even, like 0.5 and 0.5, you're going to have a faster response, but you're not going to have as smooth, but still pretty smooth. And so anyway, I found 0.7 worked out pretty good. We still got a really fast response, but a really smooth change. It took away most of the spikes. And just take your previous distance. But that's really what you're doing. You're doing a certain average, it might not be the same ratio, but a certain average of your current distance and your previous distance. That way, if there's some really weird distance that you suddenly get, right, you're not factoring it that much. You're only taking that weird distance and timesing it by 0.3. So whatever the spike was, it won't affect your program as much. And then obviously you reset the previous distance to whatever the current distance you just read in. That's a lot of work. If you're really interested, just Google math complementary filters. It's basically a software way to, help with a hardware problem. These are not the best sensors. They're fairly inexpensive. You get what you pay for, sort of thing. Okay, moving on. And then we just return the distance. Handle LED color. Again, I take in a parameter of type distance. So the argument you'll pass in is the distance that you calculated. And then if the distance is less than or equal to distances sub-zero, so again, I have an array of the distances, remember 3 distances. If it's greater than the element stored in the first element of that array, well, then I'm going to set the color to red. I'm going to call set color function and pass in red. The set color function takes in red intensity, green intensity, and blue intensity. Obviously, this is just going to be full red. And then if the distance is less than or equal to the second distance, and by virtue, it's going to be greater than this distance, otherwise this would have been called, right? So if it's obviously greater than that, but less than this, we're going to make it yellow. And then if the distance is less than or equal to the last element in that array of 3 elements that I store distances, if it's greater than that, I'm going to turn green, the LED green. Now, else if I've enabled the blue LED, this is a Boolean flag that I'm using for the coding challenge to increase the number of colors I have. If that's enabled, then I'm going to set the color to blue if I'm past this last distance. Because again, remember, this color is going to be green if the distance is less than or equal to that distance mentioned, the last element in the distance array. Let's say 30. Let's say this starts off at 10, 20, 30. So it's going to be red if I'm less than 10, which is the distance in the first element of the array. It's going to be yellow if it's less than 20, which would be the second element in the array. And it's going to be green if it's less than 30, the third element in the array. However, if I have enabled blue LED on any other distances, meaning above 30, whatever this last value is, I'm going to be blue. Else, I'm still going to be green. So again, if I've enabled it, I'm going to be blue. Else, I'm going to be green for all these distances. This set color function, we've shown this before, just takes in 3 int values and calls the analog right 3 times on the red pin, the green pin, and the blue pin, passing in the appropriate amount of PWM value from 0 to 255. So affecting the color. I'm going to try to be a little quicker. This show menu function basically just outputs this menu to the serial monitor. This function here, handle menu selection, takes in the char, types in what they've pressed, 1, 2, 3. I've since actually added 4 and 5 to this code, but I've already had this printed off, this PDF. But 3 adds a color, I think 4 allows me to disable the color, and then 5 just allows me just to display. If I just decided I don't want to click anything, I just want to keep displaying. So again, I can show that quickly. See the menu, I've added the 4 disables the 4th color, and 5 just display distance readings as is. So if I just do 5, I'll just display readings. Oh, I think I switched something, that's why. And then the handle menu selection, so it just takes in that char, whatever you typed in, and if you typed in 1, I'm going to set the distance limit. I'm going to call a function to set distance limits. I'm going to change the distance limits. And I'm always going to set the show menu to flag to false, because I was just showing the menu, but now I click something, I don't want to show the menu anymore. And then I break. If you select number 2, I'm going to toggle the units, which is just going to go back and forth between centimeter and inches. And again, setting the show menu flag to false, because I don't want to show the menu, I want to show my distance measurements. Enable fourth color, I call that function, and set this flag to false. Disable fourth color if you've chosen, you just want 3 colors again. Number 5, it just says, I simply just go show menu flag equals to false, so I don't show the menu, and then the distance measurements just continue to show. If at any point you type in the character M, when the distance measurements are showing, it'll show the menu. Again, you don't have to, you can actually just type in the values if you remember them, or you can show the menu by pressing M. And the default value will just be to show the menu, because you've typed in something weird. I'm just telling you, hey, invalid selection, try again, and I show you the menu. And these are all the functions that do that. Set distance function, again, I just prompt the user to enter 3 distances, and while serial.available equals 0, so basically while they're not typing anything, I just wait for the user input. As soon as they type something, I'm presuming they've entered 3 distances. I'm not doing really error checking on that, and I'm just going to use a for loop to assign those distances that they've typed in using parse float, because I'm passing them in as float variables, and I'm assigning them to the elements of the distances array I've created. And then I just say, hey, new distance, new limit set. Toggle units, I simply toggle the Boolean variable. Use centimeters equals not use centimeters. So if it was true, it becomes false. If it was false, it becomes true. And I just output a message saying units to centimeters or units to set inches. And again, this is using this tertiary operator where, depending on this value, if it's true or false, if it's true, meaning use centimeters is true, then I'm going to output a message saying, hey, units set to centimeters. So I'm going to output what comes after the question mark. If it's false, I'm going to output what comes after this colon. If this is the function for enable fourth color, I just basically enable the blue LED, Boolean flag to true. And I just output a message to the serial monitor. If they want to disable it, the disable function simply disables it. It toggles it. Again, you could have done this directly in the code, but I like abstracting the code and having a function, even if it's a simple 1 or 2 liner like this. It just makes it really clear what's happening when you read the loop, and there's a lot less lines of code. It's best to use modular coding, in my opinion, functional coding, and abstract the details away. Print distance, this just prints the distance. Again, I could just do this in loop directly, but I'm just printing, the distance in the particular measurement unit to the thing, and wait for user input. So whenever I'm waiting for user input, whenever I output the menu, I don't want to keep scrolling the distance time. So basically, I just enter a while true loop, and while true, I basically, if serial.available is greater than 0, I'm going to break the loop. I'm going to come in here and ultimately break the loop. But while it's not equal to, it's 0, meaning while no one's typing anything, I'm just stuck forever in this while true loop. So I'm only going to break out if someone types something in which case I'll then read it, assign it to this char variable of type choice. I'll print it out to the user just to echo it, hey, you typed M or you typed 1. And then I pass it to my handle menu selection function, which again calls one of the other functions based on what the user typed in. And last but not least, I will mention these. I know this video is incredibly long, but I ran into some troubleshooting issues with this code, so I figure I'll mention in case it's something you'll have run into. I'll just kind of go over the highlights. The first troubleshooting issue is basically the fact that I'm using an interrupt approach instead of using pulse in function. I originally just used the pins that they suggested with their code, which I think the trigger and echo pin were on pin 11 and 12, and pins 3, 5, and 6 were the PWM pins that the LEDs were on. I changed what I was doing. I decided to use interrupts, but I forgot to change the pins, so I had my echo pin on pin 11 or 12, which doesn't work, because if you're going to use interrupts, there's only 2 interrupt pins on the Arduino Uno, and probably other Arduinos, the Nano as well, and that's pins 2 and 3. So make sure your echo pin, if you're using the interrupt approach, your echo pin is on the interrupt pin, either 2 or 3. Then I ran into some other issues that weren't really that important. Third troubleshooting issue, if your RGB LED or your distance measurements on the serial monitor aren't working, the solution for me was adding the following code. I forgot to add this code, which was my time functionality code. These are the global variables. Again, my time functionality code, and in the loop, grabbing the current time using the millisecond function, and then checking if the duration from the time now to the last time that you sent out a trigger pulse, if that's greater than your delay, i.e. 60 milliseconds, well then I need to update the last time I sent out the trigger pulse to now, and call the trigger sensor. So I forgot to put that code in, and none of my stuff was working. None of the LEDs were working, distance readings weren't working, it was just a mess. The other troubleshooting issue I ran into, I didn't like the scrolling textual display where it's just showing distance the whole time. My menu would show up for like an instant that you would have to be super quick to read, and then it would disappear, and then so it was useless. So basically I just needed to figure out a way to make the menu still, and the menu still worked when it was doing that, but I needed to make it more aesthetically pleasing. Basically stop the scrolling text and stop displaying the distance at that point, and just display the menu until a user types something in. And that's where my Boolean flag, show menu flag, came in. And in loop, I added this in the main loop of the function. If not show menu flag, meaning if you don't want the menu there, well then call the print distance function passing in distance. So you're printing the distance string. Otherwise, show menu. And then I had this other function, wait for user to input something. So again, I stopped scrolling, and in all of my case statements, every case statement inside the switch function associated with the handle menu choice, I set show menu flag to true in number 4, and then I set it to false when I handled it. But basically I basically just needed to stop scrolling of the menu. So this all just shows kind of the code associated with having that scrolling stop. And then last but not least, the blue LED was enabled at the start of the program, which I didn't like. I ended up doing something that was enabled right away. Because of the way I made the array. So I didn't want that. I only wanted the 3 original colors to show up, red, yellow, and green, like the original circuit, and I only wanted the blue LED enabled if I enabled it. So the solution, again, as usual, was just to create a Boolean flag that I could toggle on and off as the user chose to enable the blue LED or not. So I would toggle it from true to false. So if the Boolean enable blue LED was false, by default at the start, so that I just had the 3 colors. And again, that's an incredibly long video. Thanks for watching. Hopefully you learned something about the HC SR04 ultrasonic module. It's a great little piece of kit. Can be used in a lot of projects. We're going to be using it at the end with our autonomous driving car. So hopefully that helps. Again, thanks for watching. If you have any questions, post them on the forum.